Have you ever just stopped and wondered what really happens in that tiny moment after you write some code, but before the computer actually gets it? Well, today we're going to peek inside what you might call the brain of a compiler. We'll explore the really elegant process that turns your text into something a machine can actually understand and run. So let's start with a basic question. How does a computer even read our code? You might think it just reads from left to right, kind of like we'd read a book. But that's not the whole story. It's actually looking for something deeper. It's searching for structure. You know, it's funny. Remember back in English class when you had to diagram sentences? Well, it turns out your computer does almost the exact same thing. It builds something called a parse tree. So for a simple command like 3 plus 4, it breaks it down into its core parts, 2 numbers and 1 operation. And that tree, that simple structure, is everything. It reveals the hidden grammar of the code. And that brings us right to our first big idea here, code's secret grammar, because that's really what this is all about. Just like any human language, programming languages have their own strict formal grammar. And the process of checking your code against that grammar, well, that has a special name. It's called parsing. And at its heart, parsing is just the job of figuring out the syntax, the structure of your program. It takes that whole stream of code tokens, and you can think of tokens as just the individual words and symbols, like if, or a plus sign, or a number, and it figures out how they all fit together to form one coherent thought. And this isn't some abstract theory either. This is happening constantly, in real time. It is the invisible grammar check that runs every single time you're typing in your editor. You know that little red squiggle that pops up when you forget a semicolon? That's the parser. It's basically the compiler tapping you on the shoulder and saying, hey, I'm a little confused by the structure of what you just wrote. Okay, so let's talk about the Lookahead superpower. Because as you can probably guess, this whole process isn't always so straightforward. Sometimes, even for a computer, the rules of a language can be a bit fuzzy, ambiguous, and that can lead to some real problems. Imagine a simple parser, just chugging along, reading your code from left to right. It can run into a situation where it has 2 totally valid choices and absolutely no clear way to decide which one is the right one. It just gets stuck. And this right here is the classic example of that puzzle. It's famous in computer science, is called the dangling else problem. So you have an if statement, followed by another if statement, and then a single else. So here's the question. Does that else belong to the inner if or the outer one? Based on the rules of the grammar alone, either one could technically be correct. So how does it decide? This is where the real intelligence of a modern compiler has to kick in. When it's faced with this kind of ambiguity, how in the world does the parser make the right call? Well, in a way, it kind of cheats. It gets a superpower, the ability to look ahead. It just peeks at the very next symbol, the next token in your code, to get a tiny clue about which path it should take. This ability to peek into the future, even just one step, is what makes these parsers so powerful. And this whole idea brings us to a specific family of parsers called LR parsers. The name sounds a little intimidating, but it actually tells you exactly how it works. The L just means it scans your code from left to right. The R means it builds that structure, that tree, by finding what's called the rightmost derivation. And the little K in parentheses, that's the superpower. That K tells us how many symbols it's allowed to look ahead to make a decision. All right, our next section, power meets practicality. Because, having a superpower usually comes with its own set of challenges. The more powerful and intelligent the parser gets, the more complex it becomes. And this is where compiler designers have to make some really smart trade-offs. So the most powerful version of this is called a Canonical LR parser, or CLR for short. And it is brilliant. I mean, it uses every last bit of information it can to make the most accurate decisions possible, but all that intelligence comes at a steep price. It creates a truly massive number of internal rules or states to keep track of every single possibility. A good way to picture it is to think of these states as a giant map of every possible decision the parser could make at any point in your code. For a CLR parser, this map becomes so enormous, so detailed, that it's just too big and way too slow to be practical for real-world use. So what do? You need the power, but you can't afford the slowdown. Well, this is where compiler designers came up with a really elegant compromise, the LALR parser, which stands for Lookahead LR. And this is the genius of how it works. An LALR parser looks at that giant map of states from the super powerful parser and realizes, hey, wait a minute, a lot of these states are really, really similar. If you look here, for instance, states I3 and I6 are almost identical. Their core job is the same. So the LALR parser just says, let's merge them. By merging these similar states, it creates a much smaller, much faster map that's still powerful enough for pretty much every situation you'd ever encounter.
And this compromise isn't just a neat trick. It's so effective that it's become the standard. This quote is from the legendary Dragon book. It's basically the textbook on compilers. And the authors make it clear. LALR parsers have become the method of choice in the real world. They are what's running inside the tools we all rely on every day.
So let's wrap this up and talk about your compiler's brain. After this quick look inside, what are the main takeaways? What should you remember? Okay, 3 key things. First, parsers are what give your code its structure by checking it against a formal grammar. Second, when they get confused, the powerful ones use that look-ahead superpower to peek at what's coming next to make a smart decision. And finally, the LALR parser is that beautiful compromise between raw power and practical efficiency, making it the engine inside the tools you use every day. So, the next time your code runs perfectly, or your editor instantly finds a typo for you, maybe just take a moment to appreciate the quiet, elegant work of the parser. It's a good reminder that behind every seamless digital experience we have, there is a deep and thoughtful structure working silently to make it all possible.